Hello guys, I'm Jack. This is cycl4 presentation video. So we'll talk about open shortest path first in this section, and I will give a lot of example of pictures to make you guys understand in easy way. Let's start with OSPF. So what is OSPF? It is the meaning of open shortest path first, and it is used for the company and hospital or college. It is appropriate to be used in huge networks. Also, when many OSPF routers are part of the same network, information about all of the routers in the network are learned by all of the OSPF routers within that network too. And we call it neighbors. Also, in this picture, as we can see that I did show IP route and there are all letters here, which is OSPF. And some things that basic information we should know is routing protocol and routed protocol and routable protocol. So, routing protocol, a set of messages, rules, and algorithms used by routers for the overall purpose of learning routers. Routed protocol and routable protocol. Both terms refer to a protocol that defines a packet structure and logical addressing. It means that the protocol which can be used to send the user data from the one network to another network. Routed protocol carries user traffic such as emails, web traffic. Well, I would say IP is the most common routed protocol. So, IGP routing protocol algorithms. It is mounted on the network device, router, responsible for routing, and it allows you to select the optimal path for the destination network. Routing refers to a process of transmitting information from one source to the destination through the Ether network. In contrast, the term bridging is similar, but the difference is that routing occurs in the network layer 3 in OSI 7 layer, and bridging occurs in the data link layer, which is 2. Let's see the RIP one. As we know, RIP is limited in 15 hops, and as we can see in the picture router B, there is a one hop route directly to A through this S0/0/1 interface, and B also can hop twice through router C, like 1, 2, through gigabit 0/0 interface, and we can see the router B chooses the lower hop count route. The right side of it is OSPF. In this feature, we can think that using default settings based on the interface bandwidth to match the actual link speeds can make OSPF, which means that users can use hop to make a direction one way or multiple path. Also, OSPF uses link state protocol. It does not have limitation of the number of hops and fast coverage time. Topology information and LSAs. Link state advertisements means that link as interface. State means status. They do advertise each router's link state database and synchronize. Also, at the end of the process of flooding the information to all routers, every router in the same network has the exact same information about the Ether network. And here's another example. In this picture, there are LSAs, and each LSA is a data structure and have information about the network topology, and LSDB is just collecting all of LSAs to a router. Now we have three main phases of how OSPF routers accomplish the work of exchanging LSAs and calculating routes. So first, becoming OSPF neighbors, a relationship between two routers that connect to the same data link. And next, exchanging databases, the process of sending LSAs to neighbors so that all routers learn the same LSAs. Next, adding the best routes, the process of each router independently running SPF on their local copy of the LSDB. So, let's start with the easy one, becoming neighbors. Well, this idea is very easy. When one router say hello and visit the new neighbor house and meet their neighbors, it is becoming neighbors. Each router will learn their names and start talking. They will be able to know about their information and sharing data. We call that OSPF hello messages. Hellos in turn list each router's router, which is RID. It serves the router's unique name of identify OSPF. And the information of it looked like this. Each router, they're communicating as neighbors. Next. So we're going to do the exchanging the LSDB between neighbors. So we talk about OSPF neighbor state two-way communication, which means it is already ready to begin a two-way exchange of the LSDB2. When two routers are linked, they can process the database exchange. So first, when routers decided to exchange databases, they do tell each other a lot of LSAs in their databases, and each router will check LSAs it already has, and they ask the other router for only the LSAs which is not known yet. And this is how it should look like. The center shows the protocol messages, and the other outer items shows the neighbor states at different points in the picture. And also we can check the routers exchange the LSAs inside LSU packets. And next, OSPF LSAs do not have the specific information that a router needs to add to its IPv4 routing table. Basically, the router can't just copy from the LSDB into IPv4 routing table. In addition, router must do some SPF math to choose the best routes. And engineers do not need to know the details of how SPF does the math. They just need to know how to predict which routes SPF will choose as the best route. Once SPF has identified, OSPF calculates the metric for a route. And this is an example with R1 to subnet X to the down below in here. It looks so complicated, but not. It shows the router 1's best route to the 172.16.3.0 starts by going through router 5. So in this picture, if you can do the basic math, it'll be fine. So I will divide it into 3 sections: left, middle, right. What we have to do is just add them. So the cost will be 200 on the left and 100 in the middle and 125 on the right. And now what? We have an answer in the middle one. It is the last cost, so we choose this way to send the data. Alright, chapter 20, implementing OSPF. Okay, implementing single area OSPF version 2. Look at this picture. It shows the relationship between the OSPF configuration command. The configuration creates a routing process in one part of the configuration. It doesn't name the interfaces on which OSPF is enabled. So, in here, we see the defined process ID and set it router, and network IP address with defined area number 2. Next. So as I mentioned, wildcard. What is wildcard? It is used to specify a range of network address used with EIGRP and OSPF, which are routing protocols. Okay, so I will make it easy to understand. We have 3 hosts and router. And as you know, the router is directly connected to 3 subnets. So we choose write PC to advertise in here. 10.0.1.0/24. Subnetting EIGRP. We will use the wildcard mask of 0.0.0.255. Whoa. Why? Don't worry. It's like this. We need to convert the IP address in binary. So 10.0.1.0 is shown like this. Sorry, I don't want to count zeros, but cause maybe someone might say I overcounted, so I just wrote down in here and check the point of this. So the 0 bits of the wildcard mask should be matched with the IP address for sure. As we can see in the below picture, the last octet doesn't have to match because the wildcard mask bits are all ones. But the first 24 bits have to match. Why? Because the wildcards are 0, which means they should find X, which means here. So in this case, we need only single network that will be matched with 10.0.1.0. And in the book, it shows the wildcard mask example in here. So I mentioned 0.0.0.255, which is compared the first 3 octets only. Ignore the last octet when comparing the numbers. Every wildcard has different meaning, so we should memorize it. Basically, a wildcard mask value of decimal 0 in octet tells iOS to compare the numbers, and 255 tells iOS to ignore. So I think this is really important information, so I think Sterling gonna ask you guys to memorize it or not, but I'll just memorize it. I think it's really important. And now I will show IPv4 routes. So there is show IP route command, and as I said, it will show all interfaces. And down below, if there's all letter, it means what? OSPF. So in this picture, router 4 has 2 connected subnets and 7 subnets exist, which means the router should learn 5 OSPF routes. And here's some command that we can use. Okay, so show running config to examine the configuration if we have enable mode access. Second, show IP protocols to recreate the OSPF config. And the last one, show IP OSPF interface command to determine whether the router enable OSPF. Next, Chapter 21. OSPF network types and neighbors. So, as we learned, show IP OSPF neighbor command will show the result like this. Router 1 lists 234 neighbors, and router 1 dynamically discovered the other routers. And 4444 is DR, 3633 is BDR. And what is DR and BDR? So, DR means designated router. It does special work in multi-access as Ethernet. and BDR is just backup DR, which will receive the DR's functions when DR is not working well. And DR other, I don't know, like people say it is DR other, but I thought it was drother, but yeah, DR other will form adjacency with DR and BDR only. A router that's neighbor DR nor BDR, they're not. And I brought some pictures with DR BDR and DR other. Router 1's neighbor adjacency with DR router 4 and BDR router 3. But as we can see, in router 1 has total of 3 neighbors, which is all reachable with gigabyte 0/0. And if the interfaces are connected like this, we can check with show IP OSPF interface brief command like this. So it shows 2/3 DR other. Well, yes, obviously it is DR other, and 2 means 2 neighbors in gigabyte 0/0 with 3 total neighbors on the interface, like we saw. In addition, if you want to see the setting, use the show IP OSPF interface command. So configuring to influence the DR BDR election. So it is like this. BDR is backup of DR. So if the DR fails, BDR will replace and becomes the DR, and new BDR will be elected. And when a better router enters the subnet, there are no preemption of the existing DR or BDR. Okay, so I brought this one too. So they set router 1's interface priority as 99, and after config it shows router 1's interface values is 99. Well, we can see in here. And OSPF neighbor verify briefly shows the IP and state too. And 4444 shows DR, 3333 is BDR. So what we'll do is forcing a free election by failing the LAN switch, which is connection between the 4 routers. And what happened? 4444 became BDR, and 2 and 3 neighbors are DR other. Wait, so which is DR? Router 1 became DR. It had higher priority, and 4444 just became a BDR. Now we can check down below in here too. Next is finding duplicate OSPF router IDs. This is really interesting. So for example, router 1 and router 3 both are using read 1111, and they automatically generate a log message for the duplicate OSPF read problem. In this case, just use show IP OSPF to list the read. So first line, show IP OSPF will show the duplicate use of 1111. To solve this, they have to change, one of them should be changed. So we can put router -ID 3333 and its exact mode command clear IP OSPF process. So the OSPF will use the new RID. Next, shutting down the OSPF process. Well, I love shutdown command, and as other protocols, we use shutdown and no shutdown too. So when routing protocol is shut down, iOS does this. It clears the LSDB and IP routing table of any OSPF learned routers. In this picture, first, we just show IP OSPF neighbor to check 2 neighbors and shut down. The same command list no neighbors, and used show IP OSPF interface brief will list the enable OSPF, and they're down. which means they're not working. And at the last, show IP OSPF command will show shutdown state. What a nice command. So this is my citation, and thank you.